Okay, so this is cluster analysis, the first type of machine learning. Let us see how we come to this topic. So if you look at the previous diagram that we have the big topic is data mining using machine learning. So what we have here is we have supervised. Supervised means we are doing classification and regression. Unsupervised, we are looking at clustering. So now we are looking at clustering. So clustering analysis, so specifically on k-means. Okay, so that is our first method that we will learn today. So if we look at the um, definition, basically in clustering, you will learn different ways on how to analyze your data. This is different from classification because classification is more into supervised learning, and you also learn how to do clustering using how it works, how do we define the center, and so on. Um, and also you will learn the step needed to apply clustering to real world tasks. So we are looking at the real world punya data, and then we look at the command that we use to perform clustering. Okay. So in trying to understand clustering, basically we perform grouping, or we divide the data into cluster depending on the content of the data, depending on the characteristic of the data. So basically, we are looking at similarity here, similarity in terms of the value of the attribute that we have. Okay, so similar record will be cluster in the same cluster. So depending on how much differences that we have, we will assign them to different cluster. Okay. So clustering normally used for customer segmentation, for marketing, in which they will look at our purchasing behavior. So based on that, they will be able to perform marketing based on targeted customer. Um, Clustering also can be used to detect abnormal behavior. This is what we call outliers. So if you fall outside the cluster, they call it outlier. So when you have outlier means you have abnormal characteristic or behavior. Okay. Um, Clustering also can be used to simplify large data set by grouping them into several clusters. So based on the feature that you have, you will be grouped under different cluster. Okay, so these are the application of clustering. Okay, so clustering will tell you which group of example are closely related. So you would be able to see how many member belong to one particular cluster. Okay, so this is to facilitate um, collaboration, or you want to look at certain item are grouped together because they are having the same characteristic or producing the same output, or any example. Okay, so this is the example that we have. So basically, we are looking at two things here. The first one is how compact they are. So this is the intra cluster. Intra cluster means the compactness of the cluster. Okay, intra cluster distance are minimized within the member of the same cluster. We also looking at the intercluster. Intercluster referring to distance between cluster. So that is the intercluster. So in looking at the clustering, we will study how do we use the compactness and the separation between cluster to measure the quality of cluster that we have. Okay, so we as a computer scientist, we are looking at how do we form a good cluster, how do we evaluate a good result of the clustering that we have. So we will look into this. So at the end of the session, we will have a formula on how to compute inter and intra cluster. Okay. So if you look at these two, one is very compact and far away separated, which is this one. So this one is they are not as compact as the left one, and they are not separated away from each other, far away. Okay, so this is a better quality of clustering result. Okay, so the idea is we want to have the intra cluster to be very small, and also the inter cluster to be very big. Maximize the inter cluster and minimize the intra cluster. Okay. So if you look at here, how many cluster do we have here? Can you guess?
Two,
Two,
two clusters, two.
two, okay,
Yes.
or four, or six. So it could be two cluster, or it could be six cluster, or four cluster. But the way we decide which one is the best one, we have to look at the overall calculation for the compactness and also how well they are separated. So we will use some formula to decide which number of cluster will give you the best result. So basically, we are looking at the compactness and also how far they are separated, and we will compute the overall value, the overall quality of that cluster. Okay, so by looking at the um, distribution of the item only, we will not be able to tell. Okay? So we have two type of clustering. So the first one is called partitional clustering, and the second one is called hierarchical clustering. So the partitional clustering is just the round one. We call it non-overlapping clustering. Okay, so the hierarchical one, this is a set of nested cluster organized as hierarchical. It's like a tree format. Okay, so this is partitional clustering. There is no overlapping, right? And this is hierarchical clustering. So basically, we could have, if we group this together, we will have one cluster. But if we look at the cluster over here, then we will have three, one, two, three. So if we look at here, then we have one, two, three, no, one, two, three, four elements. Okay. So this is what we call hierarchical clustering. Okay. So for this one, for example, if we want to have two cluster, then we look at here. So we will have one and two cluster. Okay. So how do we perform the clustering process? Basically, given the data that we have, we will look into how many cluster do we prefer. So the K here refer to the number of cluster. Okay. So let's suppose we want to have three cluster or five cluster. So we say, okay, we set K to be 3. So once we know how many cluster we want, then we say, okay, I will pick randomly from the um, data that I have. That 3 point will be my initial centroid. Okay. So what happen is the remaining of the data will be assigned to the nearest centroid, the nearest center. And then once we assign them, then we recompute the centroid. So um, if you see this illustration, let me, okay. So this is the original point. Okay, we could have the optimal clustering like this, okay, or we could end up like this. Okay, so basically this one we cluster used based on this, but this one we have this clustering result. Okay, so the result will depends on where you get your initial center, but that one will be picked randomly. So the best way to get the best result is to run your clustering few times, and then you get the smallest value or the best quality of cluster. Okay, so if I run through the step by step, for example, k equal to 3, so I pick my center randomly here. Okay, so the remaining of the data will be assigned to the nearest center. So for example, this one will be assigned to here because this is the nearest uh, center. So for example, this one here will be assigned to here also because this is nearer to here. Okay. So in computing the distance between two records, we will use what we call it Euclidean distance. So you can use Euclidean distance or cosine distance. Okay. So once we have assigned all of this, so what happens is that we will recompute the center. So recompute the center means we take the average of all the value that we have in that particular cluster. So for in this example, my new center will be here for the green. New center will be here, new center will be here. Okay. So what happens next is I will update my center. Okay. So we repeat again for the remaining of the member or the data, we will assign to the nearest initial center. So once we get the assignment done, then we will find the new center again. The new center may be here because depending on the structure of your cluster here. So your new center is here. So this is the structure of your cluster is that, maybe your new center is that. Okay. So if we start from the beginning, okay, so we have this one. So we keep updating the center until there is no changes. So we're done with that. So that's how we get the optimal one. Okay. So this is highly depending on where we select the initial center. So they are selected randomly. So in order for you to get the optimal result, you need to run them a few times. Okay. So this is the iteration. So how the number of member and also the membership of the member change over time when you change the center. Okay. So how do we apply this one in the real world application? Okay. I think Afif already took the information retrieval, right? So you will have a faster understanding here. So for example, here we have 7 documents. We have 7 documents. Okay. So each of the document will have term 1, term 2, term 3. This is the keyword that we have in that particular document. So this number telling that keyword T2 exists 4 times in document 1, and so on. So we have all this number. Okay. So for example, we want to cluster this document into 2 clusters. Okay. So we will randomly pick the center. So in this case, we will have this one. So this document 3 and document 6 to be the main initial center. So what happened? We assign all the remaining document to the nearest center. So we do this one, we compute the difference. So this is the Euclidean distance. So meaning that we take the 3, find the differences, square, and then add with the next one, 4 minus 2, square them, and then 5 minus 5, you take square, and then 1 minus 3, you take the square, and then you add up everything, and then the total you just take the square root. So this is the distance between document 1 and document 3. Okay, and since we have 2 center, so we have to compute the distance between document 1 and document 6 again, because we want to decide now document 1 should belong to document 3 or should be belong to the cluster in that has document 6 as the center. So once we have computed, so the smaller the value, the nearer they are to the center. So for this one, we pick this one. So that means document 3 will be assigned to the cluster that has document, no, document 1 will be assigned to cluster that has document 3. So we have this. Okay. So the next one, we will repeat again for document 2. Okay, for document 2 again, we find the distance where we want to put to the cluster that has center K1 or to the cluster that has center K2. So based on this is a smaller value. So we say, okay, document 2 will belong to uh, this cluster. Okay, so we will repeat for document 4. So document 4 belong to the second cluster, and then document 5 belong to the first cluster, and document 6 they belong to no, document 7 they belong to cluster 1. So this is the cluster that we have for first iteration. So remember that just now when we show the illustration, once you have assigned all the remaining member to the center, then we need to find the new center. So once we have um, reached this stage, then what we want to do is we know who are the member of the cluster, then we get the new center. So how do we get the new center? It's just by adding up this value and divide by 5 or take the average. So you get this. So this is the new center for document, no, new center for cluster 1. This is the new center for cluster 2.
Itu.
Okay. So now you go into the second iteration, you have new center. So you repeat again. So for each of those document, you will decide whether you want to put in this cluster or in this cluster. So we will stop if there are no changes of document membership. Okay, so that is K means clustering. Okay, so once we get the new center, then we will repeat the same thing again. Let me correct this one. So that you're not confused. So basically, this number referring to the number of times they exist. So any questions so far? So cluster analysis,
No question.
sorry.
Not yet, Doctor.
Yeah, okay. So cluster analysis is very interesting topic because it can be used easily, but it has a lot of application. Like you want to study the behavior of the student, so you can analyze them using clustering also. Okay? So once we are in this stage, then we got the new center, right? So we can repeat again our process. So we check again, okay, this one belong to this center or belong to here. So we need to compute again lah. Okay, so but now we have new center here. Okay, now since we know how it works, how we form the cluster, now is how do we evaluate the compactness of the cluster. So we use what we call the sum square of error, sum of square error. So this is the differences. For example, if you have this cluster, this is your center. So you have this member, all this member. So the sum of square error referring to how what is the total differences of all the member to the center, because we are talking about compactness. So of course we want to look at what is the total, the average distance between the center and all the member. Okay, so this is the formula. So basically um, basically we are looking at for all the cluster, we may measure the no um, wait, yeah, for all the x, for all the member that belong to that particular cluster, you want to, okay, for all the member that belong to that particular cluster, you want to measure the differences between all the member to the center. Then we do it for the other cluster also. So we do it up to k. K refer to number of cluster. Okay. So if we go back to our example just now, for example, like this, we have 3 cluster. Okay. Um, eh, okay, yang tadi itu is basically 2 cluster only in the example, but suppose we have 3. Okay. So what we want to do is, first, what we need to do is we want to find the center of this all 3 cluster. Okay. So how do we find the center? We take the average only. Okay. So we take the average of this 2.5, 2.5, 5, 1.5, 5, 3. So that is this one. So this is the center of cluster 1. This is the center of cluster 2. This is the center of cluster 3. Okay. So once we get the center, then we want to measure the distance of all the member to the center. So we want to measure what is the distance between the document 1 to this center, and what is the distance between document 2 to this center. So we will do this calculation again. So for this one, we get this center. So we take the difference between this and this one. So that is 0.5 kan? So we take the square, and then 2.5 with the 4 is 1.5, and then 5, 5, we get 0, 1.5 and 1, then we get 0.5, 5, 0, 0. Then we add up all this, then we get this one, right? So we do it again for document 2. So document 2 will have minus 0.5. So the main reason why we have to take the square is just to eliminate the sign in the number. Okay, so this one is minus 115, and then so on. So that the total is this one. So basically the total sum square will be this plus and this. Okay, so we get 5.5. Okay, so that is only this cluster. We will repeat again for the second cluster. So the value will be 52.5, and then the third cluster, the value will be 56, and the overall cluster will be this. You add up all this because this is the formula. So this is for all the k that we have. This is only for the each k1, 2, and 3. So this is the total sum of square, sum of square error. So the objective is we want to minimize this. So we want to find a cluster that produce lower value of sum of square error. So that's how we justify. So remember just now we say this could be 2 cluster, that one could be 4 or 6 clusters. So the way we justify which cluster is the best one is looking at the compactness of the cluster. So we will measure the sum of square error. There is another measurement that measure the compactness and also how far they are separated. Okay, so this is sum of square error lah. Okay, so if the reason why we need to run this one few times, because if we have this initial 3 center like this, so this is the 3 centroid that are picked randomly. So for example, we start with this 3. So we will end up this type of cluster. Okay, so which is not optimal, right? So again, we cannot visualize this one in the processing. So the way we verify is to compute the sum of square error. Okay, so this is not optimal. So this thing could be could occur because when we select the center, they are selected randomly. So that's why we need to run them 10 times to get the best option, the best choice of cluster in which the initial selected are good in order to produce the best cluster. Okay. Okay. So they said you need to run so many times. So for us to get the best result, we will have this probability. Okay, so this because the probability are referring to number of ways to select one centroid from each cluster, and this is the number of ways to select a centroid. So they are looking at what is the probability of you to get the best cluster. So your probability is 0.0036. Okay, so the chances is small. That's why you need to run them, for instance, 50 times or 100 times. Or if you have supercomputing, then you will have more more iteration or more running, so you get better cluster results. Okay. This is another example. So this is the what we call it. We're supposed to have 10 cluster, but when we have the initial center and we do the clustering, we will have this. So this is okay. But we could also have this. This is the initial center. So when they form the final one, we get two overlapping here. and this one will become one cluster. Okay? So this is just to show that the result of your clustering will highly depends on which initial center are being selected. Okay. Okay. So the solution is you have to have multiple run, or you could use the hierarchical clustering. Okay. Or you could select more than k initial centroids, meaning that you tambah the number of cluster. Okay. So this is because when we have something like this, okay, so this is original point, but the result that we get is this, okay, or maybe different density like this will give you this problem, okay, or with different shape you get this. Okay. So they said one of the solution is to have multiple centroid, multiple initial centroid to cater the what we call it density problem or data with different shape and so on. So this is for the different density. This is for the um, different shape. Okay. So they say, okay, why not we put more number of cluster? So the but the logic is there because once you have more initial cluster, then the compact the compactness of the cluster becomes smaller. Okay, and that will increase your clustering quality. Okay, any question? Okay, so if we look at the because there is another way on how we can measure the quality of the cluster. Okay, so we call it cluster validity. Okay, for supervised learning that cover classification, we look at the accuracy, precision, and recall. But for cluster analysis, we look at the goodness of the resulting cluster. So we are looking at how compact they are, or are they grouping the same type of element in the data and so on. Okay, so the purpose of evaluating them is to avoid finding pattern in noise. So we want to remove all the noise or outliers. We call it outliers. They are something. They are a record that is not in the cluster. They are far away from the cluster. Okay. We also use cluster validity to compare clustering algorithms. So this one we can, if we have two algorithm that produce three cluster, so we can measure the result by looking at the compactness and the separation between cluster. We also can compare two set of cluster. This is between k equal to 2 or k equal to 6. So we want to know which one is better. Okay. Or we want to compare two cluster is two cluster. So one having 7, one having 3. So we want to compare which one is better. Okay. So if we look into the how do we measure the cluster validity, we can divide them into three. The first one is external index. So they call it external index because they are not looking at the structure of the cluster, but instead they are looking at the type of data that you have in that particular data, in that particular cluster. So they call it external index. Internal index, they are referring to the structure of your data. And relative index used to compare two different clustering. So this one could be the sum of square or the entropy lah. So you can use this or this. Okay. So now we are looking at this one. Just now we know what is this, right? So now we are looking at this. Okay. So for this, we are only looking at the compactness of the cluster, but we did not take into consideration how far they are separated. So we will look into this, in which they look at the compactness of the cluster. At the same time, they are looking at how far each of the cluster are separated from each other. So that is Davis-Bouldin index. Okay. So and at the same time also we look at this cluster entropy. So the cluster entropy looking at the who are the member in the cluster. Are they belonging to the same class, or are they belong to the same what we call it, type of group? Okay. So we will also learn this one. Okay. So if for the external measure, we will study the entropy. So the entropy referring to how pure is the membership of your group. Okay. So this one is looking at the um, entropy of the K cluster. So we have all the cluster. We add up the entropy of all the cluster. So this is the entropy of the cluster that we are talking about, and this is the number of object in the K cluster. Okay, so basically this one looking at the quality of the cluster in terms of the class type that belong to the cluster. We will look into this one. Okay, and this how do we measure the entropy of each cluster? We will use this formula. Okay, where this formula say that okay, I'm using the probability of having that particular class in my cluster times log to the probability of having that class in the same cluster. Okay, so this is we are looking at for all the type of class that we have. Okay, okay. To illustrate this, let's have a look. But before that, I think we need to like this. So entropy highly dependence, no, not highly dependence. They require the type of membership that we have in the cluster. For example, in this example, we have A, B, C, right? So if we look at cluster number one, we have how many A? 5A to B. So how do we quantify the differences of classes that we have in the cluster? So we use this formula. So for example, for the entropy of cluster one, so we have 5, right? And 2B. So basically, we are looking at the probability of having class A in cluster 1. So we have 5 over 7 because the total is 7 here. So this is 5 over 7 times log base 2, 5 over 7. And then that is only for the A. So we need this one for the B. So this is 2 over 7 times log 2, 2 over 7. So we find the value here. So this is the entropy of uh, H1. Okay, here. So we repeat again for cluster 2. So cluster 2 we have 1, 2, and 3. So basically this is for the A. This is for the B. This is for the C. Okay. And lastly we have cluster 3. Cluster 3 we have 1A, 2B. So this is for the A, this is for the B, and this is for the C. So we compute this one, this one, this one. So to combine all these things, because the total entropy will be the summation of all the entropy for that particular set of cluster, and this is what we call the weightage tool. So the weightage here, for example, the H1 is coming from here, okay, and this coming from 7 out of the total of all member. So the 23 is the total of all member in our data lah. So this is the weightage. So for the second one we have 9 member. For the third one we have 7 member. So that's why we have that. Okay. So this is how we compute the quality of your cluster in terms of type of membership that we have in the cluster. So the aim is to reduce this, to reduce the value of entropy. Okay. Boleh follow this part. Okay. Can I proceed?
Boleh Doktor.
Okay. So now this is looking at the external validity. We also have internal validity where we look at the structure. So this time we look into the distance between cluster and also the compactness of the cluster. Okay. So for the Davis-Bouldin index, this is the internal measure. We are looking at this is the compactness of between two cluster, and this is how far they are separated. Okay, so we will do this one for all the cluster that we have, and then we take the average. Okay, so I will show you step by step on how do we perform this. So basically this one is the formula to find the center. So what do you do? No, this is the distance between all the member. No, this is the compactness of the cluster. So basically, we are looking at the distance between all the member of the cluster to the center. So this is the compactness. This is the distance between two cluster. So distance between two cluster, we will look into what is the difference between the center of center K and also the center of cluster L. Okay, so this is the distance between cluster. This is the compactness, and this is how we find the center. We take the average of all the and we divide by the number of member that we have. So this is the centroid. Okay, so having to know that we are able to compute the compactness and also the distance between cluster and also be able to find the center, then we can do this. Okay, so let's do some illustration here. This is our cluster 3. So the motive is to minimize intra. The intra means we want to have very compact, minimize. We want to minimize the compactness. Okay, and we want to maximize this, the distance between cluster. Okay, so how do we start? So the first thing that we need to do is, because we want to find the center, right? Okay, so let's suppose we are given this data. Okay, so we have center 1, center 2, center 3, and we have this data. So this data belong to cluster 1, 2, and 3. Okay, so the first step is to find the center of each cluster. So how do we find the center? We just take the average. Okay, So we add up all those value divide by 3. And this is the center of all the cluster that we have. Okay. Okay. Next, what we want to do is we want to find the distance between cluster because we know the center already, right? So this is the center. So we want to find the distance between two cluster or from one cluster to the other cluster. So we need to find this 1, 2, and 3 lah. Okay, so how do we compute them? So we use the equivalent distance. So we take the center here. Okay, for example, if cluster 1 and cluster 2, so we take the difference between this and this and this. So we get 1.83 minus 3.5. We take the square plus 2.83 minus 0.67 square, and we add up these two, take the square root, then we get this. So this is the distance between center 1 and center 2. So we can repeat that one with center 1 and center 3, and then center 2 to center 3. So we get this value. Okay, we keep that one there. Okay, so now we are able to compute the center of each cluster. We already know the distance between each cluster. Okay, so now we want to find what is the compactness of each cluster. So what we do is we take the distance of all these three value to the center. Okay, how do we do that? Okay, so for this one, we measure the distance. So which is this one, and then this one we measure the distance. So that's why we have 3. Okay, and then we take the average. So this is the value that we get. Okay, so the 0.61 refer to the compactness of cluster Q1. So since we want to minimize, right? So the lower the value, the more compact they are. So based on the result here, we can say that cluster number 2 is the most compact cluster that we have. Okay, so we have this compactness of each cluster. So now we want to apply the formula. So the dBi here. So this is the dBi here. So what happened is we will start with k equal to 1 until we reach 3 because we have 3 cluster, right? Okay. So now we take this one as our first case. Okay. In the formula, it says that for the first case, I want to take the distance between the compactness of this and that divided by the distance. So for example, this one, 2 case here. Okay. So this is between cluster 1 and cluster 2. I have the compactness of cluster 1. I have the compactness of cluster 2. I have the distance between cluster 1 and cluster 2. So I can compute this one. Now I want to do C1 to C3. Then I plug in the number, I get 0.29. Okay. So the formula here is that I want to record the worst performance if I want to value the quality. So over here, I will pick this one, the maximum, because the worst scenario. So that means for C1, the worst case scenario is when I'm trying to link with cluster 2. Okay, so the value is this one. Okay, now you look at this one as blue, right? So now we change the case now. So we go to C2 because the formula here saying that we go from K1 up to 3. Okay, now we have the C2 become blue now. So we want to check what is the worst scenario. So we plug in, okay, for example, C2 and C1. So we plug in the compactness of cluster 2 and cluster 1 and find the distance, then we get 0.38. So similar to cluster 2 and 3, we plug in the value, we get 0.2. Okay, so since the formula here is max, so that means we are taking this one. Okay, so that is for cluster 2. So we repeat again for cluster 3. Okay, so this is cluster 3. Okay, so we take the worst scenario, which is this 1.29. Then we record everything. So the final dBi will be this. So this is for cluster 1, cluster 2, and cluster 3. We take the average, okay, and divide by 3. Then we get 0.35. Okay, so if we look at the formula here, the compactness, basically we want to reduce, right? And this one, the distance between cluster, basically we want to maximize. So basically, if we want to minimize the upper value and maximize the lower value, then basically we're trying to reduce this. So that means the lower is the dBi value, the better is the quality of the cluster that we produce. Okay, so this is the quality of this cluster. You may have different cluster, like we have 4 cluster, or you may have 3 cluster but different membership. So in this one we have 3, 3, 3. You may have 1, 2, 3, 4, 5, and then this one. So this one is 3. So this one is 3 cluster, but they have different membership. So we can compare also. Or maybe you could have like this, 4 cluster with different membership. So how do we decide which one is best one? Is by looking at the value here. So for this cluster, the value for dBi is 0.35. Okay. So I will give you some exercise. You will look into that one later on. Any question so far? Okay.
No question, Doctor.
No question. Okay. So how do we apply this knowledge in the actual situation? So in the actual situation, maybe in this example, we may have a list of bike station location. So this is the location of each of the bike station that we have. Okay, so this is we are using the R software. This is how we read them. Let me, okay, so this is how we read them. So we say, okay, we will read the file that contain 2 column. The first is the latitude and the second one is longitude. So this is the position of the bike station. So if you look at the histogram of the value, so this is for the latitude, this is for the longitude. So this is the plot for x and y for the value of longitude and latitude. Okay, so this is the distribution of the bike station in one area. Okay, so for example, if you want to find 2 cluster here or 3 cluster here, so we can always perform the k-means clustering. So at the center of your cluster, that could be the service station, because that is in the middle of everybody. Okay, so how do we apply the k-means clustering? Let me go back here. So this is where we read the value and we put in this station, and then we can do summary for the value that we have. Okay, this is just to plot the histogram for the latitude only, and we put the color gray. This is we display the histogram for the longitude, and this is we are limiting the y scale to be 0 and 60 only, and the color is gray. And this is plotting the longitude and latitude of that particular value, and this is the scale size here, so meaning that they have same scale 1. Okay, okay, so the data that we have is stored in the station, right? So we take that data, and then we call this k-means, and then we just specify how many cluster we have. So we could have 2, so this is the result of 2 clustering. This is the 3 clustering. So if we uh, type, for example, if we want to look at the 3 here, so we have, okay, this is the center of each of the cluster that we have. And this tell you the size of the cluster. And this one tell you the membership cluster that we have. So that means record number 1 belong to cluster 3. Record number 2 belong to cluster 3, and so on. But this result is stored in here, 3. Now we want to combine the data here so that we can visualize the data. Okay, so how do we combine this result with the initial data that we have? Okay, so we say, okay, this is column binding. So what happened is that I will take my initial data here, and I will embed with the 2 cluster punya result and the 3 cluster punya result. So this is the result that we get. So we use column binding. So this is your initial data here. So I will combine with the cluster result, and also the this is 2 cluster, this is 3 cluster. Okay. So once we combine them, then we can we can plot them. So different number of membership will use different one. So basically, we are plotting the longitude and the latitude, and we are using the two cluster. The PC. Okay, this one is looking at the symbol that we have. So this is 1 and 2, right? So 1 and 2 they use this one. Okay, so this is the main title of the graph. This is the x-axis, y-axis. Okay, so this one they are looking at printing the center of 2 so they are using 23. 23 is this one. So they are using this to pinpoint the center. The color is maroon, background is light blue. This is the the line. So this is the background. Okay, and then this one will write the cluster ID. So the output is this one. Okay, so how do we know that we will plot them using circle? That is in here. Okay, so we will plot them using this. So PCH refer to the symbol that we will be using. So if the cluster value is 1, they will print 0. If the cluster is 2, then they will show the triangle. Okay. So this is the result for the 2 cluster, and this is the result for the 3 cluster. So we will do the same thing here. So you get so very easy for us to look into the cluster analysis. We can visualize them in 2D. This is 2D because we have two variables only. So if we have 3 variables, then we can visualize them in a 3D. But in the if we have 4 variables, then we won't be able to show like this. Okay. So 2 variable possible. We can show this 3 variable 3D and 4 variable. They just show you the result. We cannot display. Okay, very fast. Actually 1 hour over also. Okay, so I will